Welcome to the lesson on Introduction to Rational Numbers. At the end of this lesson, you will be able to define rational numbers. You will also be able to identify positive and negative rational numbers, obtain equivalent rational numbers, and express rational numbers in their standard form. In addition, you will be able to represent rational numbers on the number line. High up in the sky, above the clouds, lives Mr. Number Maker. Mr. Number Maker makes all the numbers for us. This is Naughty Yank, Mr. Number Maker's grandson. He loves to play with Grandpa's numbers. He's always up to some mischief. Wonder what he's doing now.
Now, what is all this racket about, Unc? What are these numbers? Let me see. All of them have a numerator and a denominator. And we call these numbers fractions. Let's recall our understanding of fractions. Fractions are a collection of numbers of the form a divided by b, where a and b are whole numbers and b is not equal to 0. But some of these numbers are made up of negative integers. In the first number, the numerator is a negative integer. In the second, the denominator is a negative integer. While in the third number, both the numerator and the denominator are negative integers. By definition, these numbers cannot be called fractions. Seems like Unc has created a new group of numbers. These numbers are called rational numbers. A rational number is a number that can be written in the form p divided by q, where p and q are integers and q is not equal to 0. Let's check what all numbers Unc had put into the number machine. Looks like Unc had put positive and negative integers, fractions, 0, and decimal numbers as well. All the numbers changed to the numerator divided by denominator form. Just like fractions are whole numbers, integers, and decimal numbers can be written in the numerator-denominator form. These numbers are also rational numbers. Like positive and negative integers, rational numbers are also positive and negative. Here are some rational numbers. Let us look at each one of them and see if it is positive or negative. Consider the number 2 divided by 5. Here, both the numerator and the denominator are positive integers. Here are some more examples of positive rational numbers. All such rational numbers, where both the numerator and the denominator are positive integers, are called positive rational numbers. Now consider these two numbers, minus 2 divided by 5 and 2 divided by minus 5. If either the numerator or the denominator of a rational number is a negative integer, then the rational number is called a negative rational number. Here are some more examples of negative rational numbers. Now, we come to the number minus 2 divided by minus 5. In this number, both the numerator and the denominator are negative integers. If we multiply both the numerator and the denominator by minus 1, We see that the resulting number is 2 divided by 5. It is a positive rational number. So, if both numerator and denominator are negative integers, then the rational number is positive. Here are a few more examples. Let me restate the rules for you once again. A rational number is positive if both its numerator and denominator are either positive or negative integers. A rational number is negative if either its numerator or its denominator is a negative integer. The number 0 can be written as 0 divided by 1 or 0 divided by -1. In either case, its value remains 0. Thus, the rational number 0 is neither negative nor positive. Consider two integers, 8 and -6. If we multiply both integers by 2, we get two new numbers. Now, let's make a rational number, -6 divided by 8, with these two integers. If we multiply both the numerator and the denominator of this rational number by a positive integer 2, we get another rational number, -12 divided by 16. Next, we multiply the numerator and the denominator of the first rational number, -6 divided by 8, by a negative integer, -3. We get another rational number, 18 divided by -24. All three rational numbers are equal. Similarly, we can divide the numerator and the denominator of a rational number with the same integer to get another rational number that is equal to the given number. Dividing 18 and -24 by 6, we get another rational number, 3 divided by -4. This rational number is equal to the previous three rational numbers. Such rational numbers are said to be equivalent to each other. By multiplying or dividing both the numerator and the denominator of a rational number by a non-zero integer, another rational number is obtained, which is the equivalent form of the given rational number. In this section on equivalent rational numbers, we saw that all the numbers shown here actually represent the same rational number. But what is that rational number? To find what rational number all these numbers represent, we have to find an equivalent rational number whose numerator and denominator do not have any common factor other than 1. Here, -6 and 8 have common factors 1 and 2. -12 and 16 have common factors 1, 2, and 4. And 18 divided by -24 have common factors 1, 2, 3, and 6. However, 3 and -4 have only 1 as their common factor. The number 3 divided by -4 seems to be the number we are looking for. However, my rule book says that the number we are looking for cannot have a minus sign in the denominator. Getting rid of the minus sign in the denominator is easy. We just need to multiply the numerator and denominator by -1. The number -3 by 4 that we have now meets all the conditions. Here we have a rational number whose numerator and denominator have no common factor other than 1, and whose denominator is a positive integer. This form of a rational number is called its standard form. By saying that -3 divided by 4 is the standard form for all these equivalent rational numbers, we mean that all these numbers can be reduced to -3 divided by 4. Let's see how. To reduce a rational number to its standard form, we divide its numerator and denominator by their highest common factor, or HCF for short. Consider the number minus 6 divided by 8. The HCF of minus 6 and 8 is 2. Dividing the numerator and the denominator by 2, we get the number in its standard form. Now, consider the number minus 12 divided by 16. The highest common factor of minus 12 and 16 is 4. Dividing the numerator and the denominator by 4, we get the number in its standard form. Now, we come to the number 18 divided by minus 24. The HCF of 18 and minus 24 is 6. Here, note that the denominator is a negative integer. So, we divide the numerator and the denominator by minus 6 in place of 6 to get the number in its standard form. Look what I have here. The number line. It's my favorite tool. I can use it to show all the numbers in the world. Right in the middle of the number line is 0. Now watch. Grow, grow, grow. The positive integers get marked to the right from 0. The negative integers get marked to the left from 0. Note that 1 is at the same distance to the right of 0 as minus 1 is to the left of 0. Here are some rational numbers. We can also represent rational numbers on the number line. Just like positive integers, positive rational numbers are also represented to the right of 0. Negative rational numbers, like negative integers, are represented to the left of 0. Now, 1 divided by 3 is 1/3 the distance from 0 to 1. So we divide the distance from 0 to 1 into 3 equal parts. The first mark from 0 represents the rational number 1 divided by 3. Just as the distance of 1 and minus 1 is the same from 0, the distance of 1 divided by 3 and minus 1 divided by 3 will also be the same from 0. So, we divide the distance from 0 to minus 1 in 3 equal parts. The first mark from 0 represents the rational number minus 1 divided by 3. Now, 2 divided by 3 is the 2/3 of the distance from 0 to 1. So, the second mark from 0 between 0 and 1 represents the rational number 2 divided by 3. The distance of 2 divided by 3 and minus 2 divided by 3 is the same from 0. So, the second mark from 0 between 0 and minus 1 represents the rational number minus 2 divided by 3. The rational number 3 divided by 3 actually just represents the number 1. Thus, it occupies the same place as the positive integer 1 on the number line. Similarly, the rational number minus 3 divided by 3 actually represents the number minus 1. Thus, it occupies the same place as the negative integer minus 1 on the number line. Similarly, you can mark more rational numbers on the number line. Draw your own number line and practice. I must go now and find my naughty grandson who started all this.
This brings us to the end of the lesson on Introduction to Rational Numbers. In this lesson, you learned to define rational numbers. You also learned to identify positive and negative rational numbers, obtain equivalent rational numbers, and express rational numbers in their standard form. In addition, you also learned to represent rational numbers on the number line. Represent the number minus 3 divided by 5 on the number line. Draw a straight line and mark its center as 0. As the given rational number is negative, it will lie to the left of 0 on the number line. Mark a point to the left of 0 on the number line. This point P represents the point minus 5 divided by 5, which is equal to minus 1. Mark 4 points at equal distances between 0 and P to divide the distance into 5 equal parts. Point Q on the number line represents the number minus 3 divided by 5. Verify if the given rational numbers represent the same number. The given rational numbers would represent the same number if their standard forms are the same. Consider the number minus 12 upon 8. Highest common factor, HCF, of minus 12 and 8 is 4. Dividing minus 12 and 8 by their highest common factor 4, we get the standard form of minus 12 divided by 8 as minus 3 divided by 2. Consider other number 18 upon minus 12. Highest common factor of these numbers is 6. Dividing 18 and minus 12 by minus 6 to get the standard form of 18 divided by minus 12 as minus 3 divided by 2. As the given numbers have the same standard form, they represent the same number. Write 3 equivalent rational numbers of the rational number 5 upon 3. Consider the given rational number 5 upon 3. To find rational numbers that are equivalent to 5 divided by 3, we'll multiply its numerator and denominator with 2, 3, and 4. Ten divided by 6, 15 divided by 9, and 20 divided by 12 are the 3 rational numbers equivalent to 5 upon 3.
जब कार ने हमें ये फोन मिला कर